Welcome everyone to today's inVision Tech Talks. My name is Bastian Fitz. I'll be your host today. The topic today is surface inspection, and I'll just share my screen and do a short presentation before we begin proper. So today we have presentations from AT sensors, from Euresys, and from INES.
So yes, I'm Christophe from Euresys, and I'm the vision software at Euresys. And I will talk today about EasySpotDetector, which is a new product from Euresys, and it's for surface inspection. But first, I will give a quick introduction about Euresys and Open eVision. Euresys is a Belgian company. We are specialized in manufacturing and providing vision components for machine vision. We have daughter companies around the world, but especially in Asia, where we sell most of our products. Speaking about products, we have different range, and one of these products are the frame grabbers. So we sell frame grabbers for machine vision application. So it's Co-Express or Camera Ink or other non-standard image acquisition board. Euresys also sell IP cores for FPGAs. So these IP cores implement different vision standards and also implements interfaces with sensor like the Sony range of CCD sensors. But today I will talk about vision software, so libraries, SDK. And Euresys sell Open eVision, which is a image analysis tool that implements a lot of different features for machine vision, including defect detection, subpixel measurements, alignment, character recognition, code reading, etc., etc. So I will go quickly over the different libraries. We have Easy Color and Easy Image. It's typically for pre-processing images before other processing. So it processes color and it could perform filtering, HDR, stuff like that. And then we have a range of pattern matching libraries. So to find objects in images, we also perform subpixel measurements with Easy Gauge. And with Easy Object, we could segment and measure 2D objects in images. Regarding the text and code reading, we can read the different symbology, like the barcode, the data matrices, or the QR codes. And we also provide several OCR, so optical character recognition libraries. We will soon introduce a new deep OCR libraries, which is a more advanced way to read difficult text in picture. We have a set of 3D processing libraries for example, laser line extraction and calibration, but also 3D object segmentation and measurements, and 3D matching functions to align object with reference and compare both representations. And finally, we offer a range of deep learning-based libraries, so for image inspection using neural network. So typically, we are able to classify images or to locate objects inside the image, or to perform semantic segmentation of objects in images. So that's for Open eVision. And it's important to note that eVision are not linked to a specific hardware. So you can process any images with eVision. So we are compatible with any sources, frame grabbers, files, or whatever. We have fairly high precision in measurements for pattern matching or easy gauge. We perform also camera calibration in the package. All these libraries are compatible with Windows and Linux, and we are compatible with Intel processor, but also ARM processors that are mostly used on embedded systems. And these libraries, this SDK, supports C++, Python, and C# programming languages. But today, I would like to focus on EasySpotDetector, which is a new library that are part of eVision. So EasySpotDetector is to segment, to extract defect from surface. And a quick recap first on how to do that in eVision, for example, but it's the same with other packages. You can use EasyObject. EasyObject perform simple global thresholding. So the object must be significantly contrast to be segmented. And also in EasyObject, we extract the size and the shape of the object. It's usually fairly fast and simple to use, but the image must be not too noisy and the background must be uniform. Or you can use EasySegment, which is a deep learning-based segmentation library. So it works like other AI stuff. So you need to train the model depending on your context, and then to do the inference on the target images. And usually it could be fairly slow if your image are really big. And then we introduce EasySpotDetector, who try to combine the best of both worlds. So SpotDetector will perform local segmentation of candidates and then a deep learning-based classification to produce better results. The capability of SpotDetector are typically the feature to find faint defects and contaminations on noisy images. So if your image are noisy, if the background are not uniform, if there is some texture on the image, and there is some contamination, defects, scratch, hole, EasySpotDetector can handle that. It has been optimized for really fast processing, so it's compatible for inline inspection. It's also compatible with line scan camera or area scan cameras. And there is two optional processing that are including in SpotDetector. It's the alignment of the part, so a way to find where is the object in the picture. And the second optional processing is the deep learning classification, performed after we find the best candidate in the picture. And of course, like other eVision libraries, EasySpotDetector is compatible with C++, C# and Python. So that's the general architecture of EasySpotDetector. So from a camera image here, you can perform the extraction of the region of interest. And then here we extract the spots and scratches using what we call conventional processing. So it's a really fast way to extract candidates. You can set up the polarity. So is it an object that are darker or lighter than the background? You can express some constraint on the size and the sensitivity and the shape of the object. Then if you need to, you can submit these candidates to a deep learning classifier. And there is several applications to that. I will get back to this subject later. One typical application for EasySpotDetector is the inspection of the carbon-coated copper foil that are used in battery manufacturing. So it's important in that use case to detect contamination, scratch, hole, and particles in this foil to be sure that the battery will be safe. Today, the current version could process approximately 200 megapixels per second on Intel CPU. That's approximately 60 milliseconds to process a 12 megapixel image. So that's an example of the processing of battery foil. So that's, you see a high resolution image of such foil. There is significant amount of noise in that image. And there is very small black dots like that can be easily extracted by EasySpotDetector. It's, as I said, especially efficient at dealing with noise and non-uniform background, and it can extract a large number of defects per picture. So we are not limited to some number of defects. It is also able to extract some more faint and diffuse variation, like the wavy defect here. And we have a special type of defect, which is the scratches. So scratches is, or cracks is typically a faint variation in the pixels around on the line. You can see one here. And SpotDetector is able to localize and detect this kind of defect too. And is especially capable of detecting faint defects, which are really difficult to spot normally. And so after we extract candidates, and so defect candidates, we can use deep learning classification. And there is several motivations to do that. First, the classifier here will be trained by the user. And we learned that depending on the industry, users have very different objectives. When you inspect battery, it's not like inspecting plastic foil or glasses or coated metallic surfaces. And so the user would like to have a way to train a specific classifier to do their application. And for example, the classifier could be used to confirm or reject the detections. Because the deep learning is especially good as dealing with complex shape, and by training by example, you will be able to train such classifier. You can also train a classifier to estimate a severity level, or simply to classify defect in different class and to be able to do some statistic on, or decision on this class. So how it works? The deep learning pipeline starts with an offline procedure, and then there is the online process. So the offline process is to first to gather some images of the products and use the EasySpotDetector to extract the candidates. For example, you can configure EasySpotDetector to extract all dark spots larger than 10 pixels. And EasySpotDetector will directly produce deep learning data sets which are compatible with our Deep Learning Studio application, which is the way to annotate and train a classifier. So here, for example, these are the different class. There is 3 classes here. The first is, this is not a defect. The second class is, this is a mineral. And the third class, this is organic. And so the customer here, the user, will annotate their candidates. And then when the annotation is over, could in the same tool train and look at the results, so check the results of the classifier. So after training a classifier, a file will be saved, and that file could be loaded by EasySpotDetector and used during the online process. So during the online process, images will also be submitted to EasySpotDetector. The candidates will be detected and classified by the deep learning classifier. And then we output all information on the detected spots, like the position, the size, the area, and of course the label, so the class and the probability of that class. So we think that the deep learning defect classification is fairly powerful feature of EasySpotDetector because it's allow to really have very informative information about your defect. But because it's not applied on the whole image, it can run fairly fast on really large images. Because it's custom trained, so it fits the need of specific industry. So depending on the use case, the customer could train very specific classifier. And it uses the Deep Learning Studio application, which is free in Open eVision, to annotate and train the model. Of course, other applications could be tackled with EasySpotDetector. So here, for example, there is a coated called defects. Also, the detection of some plastic film, and also defect detection on glass. So if I can summarize the presentation, EasySpotDetector is a library, software library, and in a single API and a single license, you can perform alignment of the region of interest to find the parts, the detection of the defects like particles, scratches, all dots, etc., and the classification of the defects with a custom trained deep learning classifier. So these 3 steps are included in EasySpotDetector. It has been optimized to be fairly fast and compatible with inline inspection. You can use it from C++, Python, or .NET application, and it runs on Windows and Linux system, so it's compatible with embedded system using Intel on ARM platform. It can use or not a GPU. So if you have a GPU, it will be faster, but it runs fairly fast already on the CPU alone. EasySpotDetector is not released yet, but it will be released in Open eVision 25.2. So it's the beginning of next year. So it's the February release of Open eVision. But if you feel interested by EasySpotDetector, and if you think you have some interesting application and use case, please contact us so we can provide a preview and exchange on your use case. Okay, so thank you for your attention.
Thank you. I think we have time for a question or 2. You kind of talked about it. Maybe you can elaborate a bit about the GPU processing.
Yes. So today, the GPU processing is used for the deep learning inference, of course. So the first, we don't use GPU at that time to extract the candidates. it will probably be the case at some point in the future, but for now it's only use multi-core CPU. And then we gather small images of the defect and submit them in batch to a deep learning classifier. And here the deep learning classifier could run on CPU or on GPU. Of course, you get better performance if you run the classification on the GPU.
Okay. Another question for Christophe. How does the proposed solution accommodate surfaces with significant background noise?
Yes, as I mentioned during the presentation, we designed the algorithm to be very robust to noise and to uneven background. So if the background have some gradient and some noise texture, we can still extract candidates. And that's a really strong point of EasySpotDetector comparing to other more simple approach for defect detection. And even if there is maybe sometimes some false detection, the deep learning classifier that are coming next to the extraction of candidates could maybe sort between good and bad detection. So that's why we also connect a deep learning classifier after the extraction of candidates. So yes, using both cascade method, we think that we are pretty robust to noise and complicated backgrounds.
Okay, maybe final round of questions, if there aren't any more from the audience. Christophe, I think you talked about it a little bit on your last slide, but maybe you can elaborate on what type of platform your functionality can operate.
Okay. Yes, I think it's very adaptable, flexible, I would say. It really depends on the application. So it could be the size of the images, the throughput of the analytics, so how fast we need to go. If it's really high demanding inline inspection, you will probably have to go for a PC with a decent GPU to process to classify fast the defect. But it's also possible to put the EasySpotDetector library on Jetson, for example, which is a nice platform for that kind of processing because it's fairly decent ARM CPU, multi-core CPU ARM, and then a GPU that can perform the classification in parallel. And so, yes, because it doesn't require a GPU for everything, you can really modulate the platform depending on your application. So it's ranged from simple Jetson board to a high-end PC with high-end GPU, depending on the use cases.
Okay, I think we call it quits now, and I wish everyone a good afternoon.